We should be recording now.
Yeah, looks good. All right. Cool. So I first wanted to start with a quick recap on what we covered last time, and then move forward with what we will be covering today. So as you all know, we're still working on the food ordering app, and this part of the presentation, or this section, is going to be covering how to actually create a scrollable list. So how to get to something like this in your application. So that being said, let's move forward. So quick recap, we are focused on two things, tip calculator and scrollable list. In the first presentation, we finished the tip calculator. We talked about classes and inheritance, and actually creating the front end for the app and using XML, and then did some back-end binding to actually calculate the tip. So this presentation, we're going to be looking at how we can use Recyclerview and Material Card View to get to a scrollable list that you can use in your app for multiple things. And a list is a very essential component for a lot of applications. Subconsciously, you're always using lists in your apps. So it is something, it is a core concept you have to understand before you go into development. So like I said last time, please feel free to ask any questions in the chat, or feel free to unmute your mic. All right, so that is, I'm just looking at the chat here. All right. Okay, so then, like we discussed earlier, we're going to be combining those two elements and reach the end. But I did decide to just cover scrollable list this time, and see how it goes, because I did want to keep this brief, and not go over preferably not go over an hour, because last time it went over 2 hours, and including questions. But regardless, I think that's too long for a session to comprehend everything and actually implement it. So this is going to be in a style where you can follow along. But if you're just looking at this and trying to gain some info, that's fine too. So if you are following along, then you can very easily, since that's the format I'll be following. So we created the XML layout, and we talked about how you can actually use the attributes and structure them to get to something where it's, the elements on the application are actually functional, which includes the switch, which you see here, the calculate button, the radio button, and how the radio buttons inherit from the radio group class. And we actually did some back-end binding, and we calculated the tip. We were able to calculate the tip for the app. Now, coming to the main part of our presentation today, or how to use lists in Kotlin. And in this regard, lists in general can be iterated over in using ints, doubles, booleans, or strings. But for something like this, you would need something called a Recyclerview. And in order to be able to get your list to display on the front end and also be able to interact with it, you need some interaction with the backend. And in order to bind to the backend, you need certain components, like the Recyclerview and the Material Card View, which I talked about earlier, is just to make this look more pretty. So it doesn't have to do anything with actually displaying it, but it's more of a styling thing. But we'll get to that. So that being said, let's move forward. So what is Recyclerview? I keep using that a lot, and Kotlin uses that a lot for their lists. And Recyclerview is, if I had to really dumb it down, I would say that it is just a way for the front end to be able to translate what list is being entered in the back end and then just simply display it. And the reason why it's called Recycler is because, from what I understand, is that it iterates through the list. So it recycles through the list and then it displays it in a view in the front end. So that's what Kotlin decided to go with when naming that. And that is what the Recyclerview does. But how does it all come together? So here you can see in the diagram that there are a bunch of items. And let's say there was just one item, right? And there's another component called the adapter. And what that adapter does is, which we'll be dealing with in the back end as well, is that, yes, and it is something that we deal with in the back end. So adapter is solely responsible for organizing the data, organizing the list, and making sure what's being displayed on the front end is what the developer wants to display. So you could mutate the list in accordingly and add or delete, and adapter will make sure that those additions and deletions are reflected on the front end. Now, the view holder is what you see right here, is pretty much just it's like a bunch of options that the Recyclerview can fall back on in the case that your app is offline. This offline is just an example that I'm giving, but where a view holder might come in handy. But a view holder is like a backup for the Recyclerview where it can fall back on so that it doesn't have to constantly feed in information from the adapter. So the adapter does give information to the front end and to the view holder. And the view holder is what the Recyclerview can fall back on to get some data if the adapter cannot relay live data. In that regard of additions and deletions in mutable lists, I wanted to touch upon an example of how lists really work, and in a very rudimentary sense, and also touch upon at the same time on how lists work in a class inheritance setting. I talked a lot about classes and inheritance in the last presentation, and it is always going to be a very important topic regardless of what you're working with. So I think it's important to understand really how it's all set up. So here in this code, I'm just simply going to run it first so that you're not overwhelmed by what's happening. You can see that all it's doing here is saying that order one noodles is $10 and the total is 10, right? So it's all it's doing is calculating the total from the list of options and displaying that. So it's a very rudimentary list of things, and then it's all it's doing is calculating. But what's happening in the code here, although basic, is very important to understand. So the first thing that we're doing is this is not part of the food ordering app. This is just to explain you how lists work in a very basic sense. So the first thing, this open class item, what does this open do? It declares the class as a base class. So you can inherit from this base class just by declaring a class. So you don't have to, we're specifying that this class is the base class, and this is where we want most of our classes to inherit from, if not all. So that's all this means. And then we're declaring a class called item, which is going to take a string and which is going to take a integer or an integer. And one of the strings is the name and the second one is the price, right? So that's done. So we're declaring a base class right here. Then what we're doing is we're declaring another class called noodles. And we're saying that item, which is this base class right here, and we're passing in arguments or parameters in the class. What are those parameters? One of them is a string, like here, and one of them is an integer, like mentioned in the open class here. So it's saying override the function toString and return a string with the name. So here, what it's saying is that I want to call on the function toString, and I want to turn this whole thing into a string, right? And then when the name, and it only will return the name, right? So this is saying that in this case, there's only one item, which is noodles, right? So it's calling on noodles every time you'll see further down the road. But in another more scalable example, it would be something like vegetables, where you would have certain vegetables under the class which inherits from vegetables, and then you would have specific vegetables that cost differently. So same thing here, right? We're saying, and by the way, I did want to mention that this colon here, I'm sure you already read this, but all it's saying is that I want to inherit from the item class, right? So it is, in Java, you'd use extends, or I think even in C#, it's extends, and you can basically inherit from the base class, or basically you could inherit from any other class. It doesn't have to be a base class, but it's always in object-oriented design, it's good to be declaring a class that is the base class with the open keyword. Then it's saying vegetables should also inherit from item, and item is again a string and an int. So right here we've declared, so it's doing similarly for noodles and then vegetables. And now this is where the class or where the list is declared for the first time. It's declared here as well. But for the first time, this is where it's declared. And look at the syntax, right? So we gave the list a name called item list. And we're saying mutable list of item. Now, what is a mutable list? Basically, in a very rudimentary sense, a mutable list is something that can be modified after you create the list. So you can add, remove, or change items depending on the way you want the list to look. So most lists should be, mutable, but it's very dangerous to have a mutable list where you really don't need one. Because if you're having a list that is set to a certain, length, and you want to iterate through that list, you want to manipulate that list. When I say manipulate, it doesn't mean add or remove. It just basically means setting a pointer and just looking at the order or doing stuff like that. You don't really want that to be mutable, because when it's mutable, it's more malleable. So it's easy to quote unquote mess the data up, right? So you'd rather not have a mutable list where it's not needed. But in this case, we're trying to demonstrate how mutable lists work, so you would use it. And we're trying to demonstrate how adding and deletion works, because that's a feature that we might need in our app. So a mutable list is apt. So here, the whole idea of creating this function of adding an item is you might say that it's redundant, because these functions right here, where it says add new item and the add all new items, it already exists, right? So why are we creating a function called add item and add all when there's already a function that exists for add and add all, right? Because all we're doing here is we're creating a function and then calling the function that already exists, and then we're returning the same function, so that we can add what we want. But if anyone is willing to take a shot as to why we'd be creating a function here if this already exists. This is already a pre-built function in Kotlin, but we decided to create a function in this case. Why do you think that is? All right. Okay. Thanks for trying, Justin. So the reason I would say here is because um, when you say add item and then add all, what we're missing to notice is that it inherits from the order class, right? And the order class is right here. So what we're trying to do when we declare these functions is like whenever we use an add all items, then it should add it to the order that we declared, not to some random um, list that we don't know what is happening there. Um, so we would have to write extra lines of code to always specify to add it in the order class and add it in the list that has been created under the order class. So once we declare these functions here, every time we use add item or add all, it will only add it to the mutable list, which is the item list that we created, right? So we have full control over what we did. We have full control over our class and we have full control over the list. Now, for example, if we did not do these two things here, then we'd have to call the function and then we'd have to specify which class the list belongs to, and then specifically add it to, in this case, the item list. So that is why declaring the function beforehand comes in handy so that whenever we use it, we can easily add it to the order. In this case, order, but it would be any class that you would like to name it, and any kind of list that you would like to name it. So don't worry about, if you're thinking that, oh, like, do I have to actually remember the syntax and do I have to actually remember what's going on here? This is just, like I said, to get your, gears working and get you in the groove of what we're going to be doing. So don't worry too much about remembering how these functions are being declared and how we're adding. We're going to go into that a little bit in a little bit here. And then that is actually the meat of what's happening. It's all this prep work, and then this is just printing. And whenever you're printing, I don't know if you guys will work with arrays, but whenever you're taking an input or printing an array, you always have to loop through that array. And in order to loop through that array, you could either do a while loop or a for loop. It's similarly, a list is nothing but a bunch of ints or strings or whatever it is, and it's nothing but an array. Although it is separated from an array, so it's not synonymous. I would not recommend using list as a alternative for saying array, but it is similar to an array. And the way it is similar is that it is a bunch of data types that are linked together. And in order to print them, you would still have to iterate through a list. And this is a for each loop. So I don't know if you've worked with for each loops in Java, but that's how. That's why we're not looking at any conditions here. We're just saying for each item in the item list, just print it. So if there was a for each here, then in Java you would say for each, but just get away with for in Kotlin. And then you are saying order one, and so remember, order, the class here is the number of the order, so it's only going to take in an int. So that is why there's only one parameter, which is an int. And then we're adding the item, adding item, adding item, and then we're saying add all items at once, right? So this is to demonstrate the add all function that we created earlier. And we can call on multiple functions as a common, I would say, in one line, and be able to. So if this right here, if this was like that, then I guess, I don't know, it makes more sense to me like this than like when it's separated like that. But all it's saying is that add item noodles, and then add item vegetables, cabbage, onion. And if you were to just have this here and not have this. All the difference is that it just wouldn't add those other items. But syntactically, you would have to um, add a dot to add items, vegetables, along with noodles, and then you add the um, order for. So notice that the order for and these things, order three, this is where uh, it's all under that variable, right? So when you say order list dot add order for, it's going to be able to understand and be smart enough to understand that order for is adding item noodles, and then order for is adding item vegetables, and then I add the whole order for in the list, right? So in one line this is what it looks like, and this is what it's doing right here. So so this makes it a little more straightforward to understand like what's going on in order for, right? So this is to just structurally make it look more readable, and that's what the core idea of adding all items in a list is all about. And then here is when it's printing the list. We already created the print function, and then it's just skipping each line for each time it prints an element, right? So print element, this just skips a line. Or I should say enters new line, that's a better. And that's it. So this is a very, like I said, a very basic understanding of how a simple string with ints and strings work. Or sorry, a simple list with ints and strings work. So now that we have a basic understanding of how adding and I guess we did talk about removing here, but there is a function called remove, and that's it. You could just instead of add item, you would have to declare a function called remove, and you would actually follow the same syntax in the case of that function as well. And there's, if I were actually to name this remove, this right here is going to not add all, but remove all, right? And that's all there is to it. So that being said, that being covered, let me go back to my presentation. So coming back to Recyclerview, like I said, items go through the adapter. Adapter takes the data in and makes sure that whatever items it has gotten, it can manipulate that list and be able to display it through the Recyclerview. And Recyclerview is more of a bigger. It encapsulates an adapter and an item in a view holder, so it overarches it. And the view holder is make sure that there are a bunch of views so the Recyclerview can fall back on in case there's no feeding of live data going on. So the first thing we're going to do is add a Recyclerview to our project. And in order to do that, I'm going to open up Android Studio. And for that, first things first, we're going to create a project, right? So let's create a project. Let me go to Android Studio. All right. And file, new project. All right, so once we click on new project, we want to do empty activity. And the name, you can call it whatever, but I'm going to call it food. And make sure your API is 19. It's just ensures cross compatibility across most devices, so that in case you're running an emulator that is not compatible, your app won't crash. So that's it for the creation of the project. We did this last time as well. Mine's called Food 2 because I already have a project called Food. And we're in the project, right? So, Kotlin always gives you a activity main.xml to build out your front end, and the main activity.kotlin or .kt is your backend, is where your main function is in the backend, is where your main activity takes place in the backend. So very clear distinction right here. The XML is and the .kt is the backend, just like last time. So next thing we want to do is add some dependencies to our project. And in order to do that, you have to go to build.gradle and locate the dependencies block near the bottom of the file. And what is this build.gradle or Gradle? It is basically where you are importing most of your dependencies. And dependencies can be libraries, projects, any kind of styling, anything that you would like in your app. And in this case, what we're doing is we're adding a dependency for material now, which is the material card view that I was talking about, which is responsible for making our app look pretty. So for example, here, you'll see as we develop that it doesn't look like that initially. These I don't know if it's clear, but there's some kind of a shadowy effect. There's a card surrounding the image. And that card is only possible through a material card view. So we go to Gradle scripts, and then we go to the module food app, right? And then here, what you want to do is you want to locate dependencies, and dependencies is right here. And now, if it's not already present, you want to add this line right here, which is implementation and whatever follows that. But mine's already there. And even when I was actually personally developing certain projects, mine already existed because I think that Kotlin in its newer versions adds the material dependency by default. But if it's not there, then you can add that line right there. So that is the setting up of the very bare bones of the project. And now we'll be looking at how we can actually set up a list of data. So for that, we're going to go to our project window. We're already in our project window. We're going to open app, right here. App is already open. We're going to go to res. Now, these are resources. And I don't know if you remember or you were present in the last presentation. We went to resources and we went to values, and then we went to something called strings.xml. And we declared certain strings depending on their names. And that is all we're going to do for this one as well. And I'm going to just pretty much, since I already have a list, I'm going to just copy paste that list. There's no logic that is crazy going on here. So don't worry about, you'll see that it's very, very basic. So all I'm doing is just declaring names for each of my strings. Right. And so that is, so like I said, I'm just declaring, assigning a name to each of my food item, whatever I want there. And I'm going to save this, right? And next thing is we're going to go to we're going to create a new package. And in order to like have all of in order to organize our project, right, we need to organize them into packages. And once we organize them into packages, then we can um, easily pull from certain aspects of our program if we want to implement certain features of our program. And that's how the hierarchy really comes down to. It's projects, packages, um, files, XML, backend.
Is it okay if you copy and paste the string in the chat? I'm too kind of lazy
Yeah.
to type it all out.
Yeah, for sure.
Thank you.
I'm glad you're following along. Thank you. Right. So I add. So you literally, yeah, no problem. So you literally have it enclosed right here. So you should have a closing resources tag and an opening resources tag. All right. Okay. So moving on. I was talking about packages. Now, like I said, you need packages to organize your program, and in order to create a package, what you need to do is you go to your and right now I don't want to go into why I'm creating the package, so that I don't go on a tangent. So let's go through creating a package, and then you understand the objective of that package or why we're creating that package. So let's go to our app, right? And then you want to go to Java, right? And then example dot this folder right here, and then which it automatically renames it to com.example.food, and then you create a new package by right clicking on it, and then you go new, and then you go to package right here. All right, and then what you want to name this for now is model. Now, this name right here, when I say model, it should make some have some. You should have some questions regarding why, what we're where we're going with this, right? Because model, as we talked about earlier, is we didn't exactly talk about model, but if you look here, right, what we're doing, we're currently adding a Recyclerview to our project, and in order to add the Recyclerview, um, any type of an architecture when it comes to app development, it follows most likely an MVC architecture, which is a model view controller architecture. And it starts from the model, then it goes to the view, and then you can actually control what you are displaying on the front end. And right now we're at the model stage. So we're going to be able to add a Recyclerview and anything we need with the model, with the bare bones of our project. So that is the reason of adding this package, right? Adding this particular package. Now, once we do that, you want to click enter or press enter. And then you want to create a new class in the model package. And then same thing, new, and then Kotlin file class. And then here you choose the class option, right? And then you want to name it. Well, you can name it anything you want, but this is going to be our base class, so I'm going to name it food, and then click enter, right? So it created this class, right, for us, and it's called food, right? And we need to make this class a data class because what we're working on currently is adding a list of data, right? And we're going to specify that this is just a bunch of data by simply adding a keyword data before the class, right? So that's enough for Kotlin to understand that this class is primarily going to contain some form of data, right? And when I'm doing these subtle things, you have to understand that you're creating an application from scratch, and when you're developing, a lot of the elements of classes of inheritance, they have to be made aware to the program. So a lot of these subtle things that we might think are obvious are not obvious to a computer, are not obvious to a compiler or a language. So making them aware is a crucial part, and that is why we have to set certain guidelines and organize and structure our program in that way. So next thing we're going to do is we're going to add a string resource ID to the constructor for of the information class, or sorry, the food class. And the way we're going to do that is we're going to add a parameter right here, right next to where the class is, where the class name is. I'm going to say val string resource ID. Now, the purpose of this is that so that we can easily pull from the strings.xml right here, right? So that we can easily manipulate our strings just with the ID of those strings, so that we don't have to point to the string by typing the whole string. We can point to it by its ID. Now, we have to create a class to be a data source. So in order to do that, what we're going to do is we're going to we're still in the same we're still in the same project, right? We're still in example.food. We've not moved away from it. We created a package called model, and we created a class called food. So now what you want to do is we want to create another package that has data as the last part of its package name, right? So we're going to go back here. We're going to create a new package, and we're going to have data there, right? So we have a model and we have data, right? And this model has a data class inside it, right? This data class is so that the model and data can interact with each other. And this data right here is where we're going to create another class, which will be the source of the data, right? And we did the same thing as before. And then we're going to create a class called data source. Right? And the class has been created, right? And here, what you want to do is, since we want the model to interact with the data source, how do we make it aware of that, right? So that is when we import our data class inside our data source. And then food, right? And model dot food, right? So right now it's not highlighted because we haven't used it yet, but I've introduced it. And then in the data source, all I'm going to do another copy paste here. But before the copy paste, I want to write some code, which is where it actually makes the list of items, right? So I'm going to say function load food. So all I'm doing is creating a function right here, and then I'm saying in that function I want it to return a list of food. And that list keyword is all it needs to understand that it's a list of something. And we return list of food. Right, and here is where this. So notice the syntax here. Okay, I don't want to go too fast for you guys. So I'm saying return list of food, and then I'm creating a parentheses. Now this is a return type. This is what it's actually going to return. The return type specifies that it's a list, and it actually returns the list that we need. So don't get confused here. This is the return type, and that's why Java is easy to understand in the beginning, because it really helps you read the code and understand what's happening. So all right, so now I'm going to just copy paste a list of food items that I already had prepared. Right, so I'm going to go to right here, and then I'm going to once I copy paste it on the screen, you'll see what I'm referring to. So here it's saying that I don't have certain images that are, there are certain images missing. So I'm going to delete that for now, and we'll see in a second here of what's happening with those. Basically, of what I'm referring to when I'm saying images, right? We are going to be importing images into our files, and we are going to be using those images for our cards. So let's make sure that, let me actually paste this. There's someone who's following along, so I'm going to paste that here. So this should be consistent with your food ID for the XML, strings.xml that we created. So if you look at the strings.xml here, these are the same IDs that we have for our data source. So all it's doing is pointing to that and saying, grab those for me and make a list for it, right? And right now at this stage, we've created a very basic list of food items, and it's going to display the string, right? So let me save that. And now we come to actually adding the Recyclerview to our project. And this is to add the list. And this part was to make sure that the food class is where most of everything will be happening. And our data source is where it's going to be grabbing the list from to be able to display it. And understand that, you know, these division of classes is a necessity, because you can't have everything in one backend file. It's just not good object-oriented design. Although possible, but it would charge a lot of memory, and it would really slow down your application. So for now, we're going to go back to something that we're all familiar with, and we're going to go to our activity main XML, right? And we're going to split it into code view and this. And we extensively dealt with this last time, but this time it's not really a lot, because we're just adding the Recyclerview to our XML layout, to our front end, so that it can actually display the list. So right here, what you want to do is you want to replace the constraint layout, which you see here. All right, so first thing, actually, you can delete the text view, which is the hello world here. We don't need that. So need that. And we're going to replace this constraint layout with something called a frame layout. And the code for that, I'm also going to paste in the chat. And this is a schema from Kotlin that allows us to actually encapsulate the Recyclerview inside the frame. And if it was just a constraint layout, all the constraint layout is doing is constraining the elements or the attributes inside the XML in a certain screen size or screen width. But the frame layout actually helps us to do more things, like adding the Recyclerview, adding a material card view, etc. So it's capable of doing more than just containing elements. So once you have done this here. Let me paste this as well in the chat if you are following along. So once you've done that here, then all you need to do is add. Now we can actually go ahead and add the Recyclerview, and the code for that is also very straightforward. It's like adding any other attribute like we have done before. But there are in order to refer or actually add the Recyclerview, we have to point to it first. So you'll notice that everything is grabbing something from somewhere, right? So we need a source for it to grab it from. And it's going to be inside the frame layout, right? So it's going to be inside it, and we're going to point to it by saying Android X dot Recyclerview, and it's also already autofilling the rest of it for us. And once that's done, there are some attributes that need to be defined. One of them is something that we already talked about in our last one is ID, and we can just call it Recyclerview, no big deal. And then we define the width and the height of our view. And that's going to width, and we're going to match parent. And then we're going to do the height. We're going to, again, match the parent. And you can see that while I'm doing this, there's already a list that's been created here. So this is what's telling the front end to create a certain list and display it. And the height and width is basically, I'm just matching it to the screen size of our parent class, which is the frame layout. And then I'm going to do Android. Now, if we want to be able to scroll through the list, we're going to have to say how we want to scroll. Do we want to scroll vertically, or do we want to scroll horizontally? And that is the syntax for that: Android : scroll bars and vertical. And then finally, we're going to add one more element or attribute. It's called layout manager, and I'll tell you in a second what this is. And you do linear layout manager. You don't need to point to it like that. You just and so what is this linear layout manager, right? So this linear layout manager is to be able to scroll through a vertical list of items that is longer than the screen of the size or the size of the screen. So that is why, first of all, you need to add so the linear layout manager takes care of a scroll bar for us. It takes care of anything where the screen or the list might overflow with respect to the screen size. Now let's run our app and see where we're at. It should be very basic, but I'm just making sure we're on the right track. So while that's running, let me get into what we're going to be doing next. So the next thing we're going to do is actually implement the adapter. So first thing we did was added the Recyclerview, right? Then the next, we need to be able to take the data and prepare it so that the Recyclerview can display it. And that's where the adapter will come in. Now, in order to create the adapter, we need to go into, I think it's done building. Let me see if it displays anything. All right. So right now there's no, obviously it's didn't crash, so that's good. We're on the right track. And right now at the moment, it's not going to obviously display anything because we don't have any attributes or elements. But it's good to just make sure that you'll have your dependencies in check, you have your classes in check, and no classes are really overlapping with each other. So once that's done, we're going to start creating and building our adapter. So an adapter has multiple parts, and you'll be writing quite a bit of code that's more complex than what you've done in this, in the Kotlin course so far. So it's okay if you don't fully understand the details at first. So like once you've completed the whole app with a Recyclerview, you'll be able to understand how all the parts like really fit together, and you'll also be able to reuse the code as a base for future apps that you create with the Recyclerview. So let's start with creating a layout for the items. And again, don't worry too much if you don't completely understand what's going on, but make sure that you have a fundamental understanding of what I'm talking about. So if you have any problems with fundamentally understanding of what's going on, then you can tell me. But don't get too involved in the nitty-gritties of the syntax or of how the code is being written, because a lot of it depends on importing dependencies and just pointing to the right things. So make sure you have a good fundamental understanding of how the different parts of the program are interacting with each other. But like I said, don't get too overwhelmed by what I'm typing or copying. So moving on, what you want to do, like I said, is create a layout for the items. And in order to create a layout, we go to resources here, and then we go to layout, and then we go to our activity main. And then what you want to do is you want to open a new file, right? You want to open a new file called list underscore item .xml in code view. So in order to do that, you want to create a new file, and then you want to call it list item, right? And oh wait, my bad. So you don't want to go in the Kotlin file option. You want to create a new completely blank file, and then you can call it. All right. So once you do that, it's going to see that okay, it knows that it's XML, right? And you want to go back into split view, and then we actually don't really need split view for now. So and then what you want to do is add a text view with ID item title, and then make sure that you have your width and height defined. And this here is something also that we've done before. It's just a pretty basic text view that is going to encapsulate a lot of the things that we're going to be doing. So I'm going to be pasting this in the chat if you guys, if there's anyone following along. But like I said, there is a reference doc that I'm planning on updating after this presentation. So you don't have to come to the chat to look at the code. You can just use that. But that once we have a basic text view, we're going to create an item adapter class. And in order to do that, we are going to go again to our main project under Java, and we're going to create a new package. Like I said, it's the project and then it's divided into packages. So that's how the program looks at organizing different dependencies. We're going to create a new package, and then once we create a new package, we want to call it adapter, right? So it's clear what it's doing. And then right-click adapter, and then create a new file class, and then call it item adapter, right? Dot. I think it should, yeah. Once you do that, you're gonna see a class that's generated for you, and then you want to add a constructor. And a constructor, like we've talked about this before, and it's also been mentioned in programming concepts a lot, where it's just, what parameters is it going to accept, right? What parameters is my class going to take in? So in this case, it's going to be a list, right? Because it's an adapter that needs a list to be able to display it to the Recyclerview. So we're going to do private val dataset, right? And what is this dataset? You'll see in a second here. And then we're going to go item. Or actually, we don't need to do item. We can just do the list. So it'll automatically import what you need. And so, but sometimes I think older versions might not. So if you just see that it's not, there's a red line there that says that it's not been imported, like, something like that. Unresolved reference is the exception. So you would have to import your library. You can also just fix it by going here and just click import here, and we'll import it for you. But yeah, so we created a class, we created a parameter for that class, and then what we want to do is create a context for the class. Now, what is this context? The item adapter needs information on how to resolve the string resources. So this and other information about the app, of course. So all that information is stored in a context object instance. So that you can pass into an item adapter instance. So I know that sounds like a lot of jargon, but what that basically means is that the list of food in this case is going to be stored under context, and that object is going to be what is used to return something using the item adapter. So it's stored under that. It's under that overarching idea of context. So we're going to again declare another parameter here, and we're going to call it private val, and then context, right? And then say context here, right? And then we're going to make sure that our syntax is fine. And the next thing we need is a view holder. So we talked about context, we talked about the data set, the parameter in there. Now we need to create a class called the view holder. So the Recyclerview doesn't interact directly with item views, but it deals with view holders. So it doesn't directly interact with the items in the list. So it interacts with a view holders, and a view holder represents a single list item in the Recyclerview. So it can be reused whenever you want. So view holder instance holds references to the individual views. So within a list item. So it can be looked at as if the view holder is a mediator between the Recyclerview and the actual items in the list. So this makes it easier to update the list, with new data, or view holders can also add information that Recyclerview uses to efficiently move views around the screen, right? So when we're scaling the app, we're making it bigger, we might need certain other views that are already prepared for us to be able to use instantaneously. So let's create a class under this and call it class item view holder. And I can see that we're already crossed an hour here. And like I said, I don't want to completely overwhelm you with a lot of information in one presentation. So in order to shorten that a little bit and get the process going, I'm going to copy paste. So this is the general idea, and now I'm going to copy paste under the class certain code, and I'm going to definitely go through the code, but I'm just letting you know that I am going to be copy pasting right now, and I will walk through it, and I'll address anything that seems out of place. But so far, I hope you're with me in terms of the Recyclerview, the item adapter, and how we need to use the view holder inside the item adapter to be able to interact with the Recyclerview. So let me actually make sure that I have what I need here and get that going. Now, like I said, I'll update this in the reference doc. So feel free to look at the document there. And I'll add a link to the document here. And actually, you know what's better? Let me do it in real time. Let me actually add a link to the document in the chat right now. And so that you can also, and then I'll add the code to that document there so that I don't have to add it to the chat. And it's going to be, in the document. So, so while I can also refer there, you can also have access to the document. So this document is shared. So whoever has the link will find it and can use it. Let me know if you can't access it with your USF email. So I'll be adding it in the end. So it's going to be the latest edition after everything. Sorry. All right, so I added it after the frame layout. Yep, and here, let me make sure that I distinguish it. Here, scrollable list, frame layout. All right. So I named it after file name of where it should be. So it's in there. So it's in the document. So feel free to look at that if you need it there, and then we can take it from there. So here, so like I said, right? So let me walk through what's happening here. The item adapter is it has two parameters. It has a context, the data set, and then it's saying I want to inherit, or like I said, colon represents extends. So it extends from the following class, right? And it says that the return type is going to be a view holder, right? It's going to be something that my Recyclerview can use, and in this case, it's the view holder. And the item view holder has two things: it has text view and image view. And the item view holder has to know what kind of items will it be holding, so that it can properly display it in the Recyclerview. So that is when it knows that, okay, well, I'm going to actually, let me see what I imported here, because I think there's something I might have missed. Recyclerview, text view, we have inflator, context, and image. Okay, so this is the image that we haven't added yet. Cool. So we're going to be adding that here real quick. And so, like I said, so it first of all, it looks at what kind of items that need to be displayed on the front end. So in this case, it's the text view and the image view. And find view by ID this is where we talked about view binding last time. and we said, you know what? Actually, I should rename this to a capital I. So you make sure that you rename it to a capital I, and the reason why I'm saying that is because to maintain consistency between the way you name classes, because classes are always start with a capital letter, and it's camel case, but front end can be lowercase, so that it's differentiated more easily. So find view by ID is the backend view binding that we talked about earlier, and it's simply able to look at the title and then is able to add it accordingly. So once that's done, this is the item adapter part of setting up things and how it actually looks at the data that's being passed through. Now here on create view holder, what is this on create is basically telling the program that on the creation of the view holder, whenever a view holder creation is called, so whenever this item view holder is called, I need to get the list item from the layout and then attach it to the parent class of the view holder. So how does that help us? Well, I'll tell you what exactly I mean by that here, right? So you want to understand that the item adapter uses the view holder as a, you could say, an assistant to be able to display it to the recycler view. And on creation helps us understand, or on create helps us obtain an instance of the layout inflator from the provided context. So the layout inflator, what is that? The layout inflator knows how to inflate an XML layout into a hierarchy of view objects. So, well, what does that mean? The layout inflator here, all it's doing is that it makes sure that this hierarchy here with the frame layout and this sub attribute under the frame layout is what is happening. So that is needed in order to make sure that the XML in the front end is laid out in a good base class and reference class manner, so that it's not all over the place. Without the layout inflator, we can't really bind to the front end because we won't know how classes are really being inherited in the XML document in the front end. And then we're looking at the onBind view holder, which is here. Now, the onBind view holder is called by the layout manager in order to replace the contents of the item view. So all it's doing is replacing the string and the image with what is in the data set, right? So depending on the position of that set of that element in the data, it's respectively able to replace the text and is respectively able to replace the image view with using the image resource ID. And then the get item count is simply to return the size of your data set. And we're going to be using that. Again, it's also from the layout manager and is used for the layout manager to be able to. When I say layout manager, the only thing I'm referring to is what's happening in the item view holder, right? So that is what is being referred to when I say layout manager. This is so this here is the backend of what's happening, right? So this is what's being differentiated. This is where a lot of the binding is actually happening. So this is a very core part of our program. And it creates new views, which is invoked by the layout manager. And in the activity main, this is where it makes sure that this is where it makes sure that what's happening in activity main is consistent with in terms of classes being inherited and classes being displayed according to what's being asked for, according to how to display the list, according to the conforms of the list. So once you add the recycler view, you have the onBind view holder. onCreate view holder, and this is all under the item view holder. So again, real quick, the item adapter has a context and the list of the food inside the context. The item view holder has a text view and the image view. And those two things are responsible for actually looking for the title and the image and then properly displaying them on the front end, so that those parameters can go in there. And then the onCreate view holder makes sure that it looks at the layout and it properly assigns the parent class to the parent class and the child class to the child class. And then getOut gets the size of our list, and onBind view holder looks at the position of the data in the list and then correctly replaces the string in the image in the front end. So every little thing has to be addressed, right? Every little thing has to be taken care of, and every little thing has to be tight, so that there's no loose ends. And then you should be, I think, good to go with at least the item adapter piece. Now we're going to go to our main activity to actually use the Recyclerview. And if I go to my main activity here, we're going to see that it's currently empty, of course. And here again, I'm going to copy paste some code. Before that, I'm going to add the main activity.kt reference code in the reference doc, so that you guys can look at it. Let's see here. Hold on, give me 1 second. All right. So the code that goes in the main activity is what I'm going to be pasting in the document in a second here. Again, like I said, the main activity was pretty much what where the main function. If you were creating like a very small program, you'd have a main function, and that main function is where you was what would be executed first, and then the main function would call certain functions that exist in your program that are separated through other classes. So that is actually the purpose of it here as well, where it looks at save instance, the state. So basically here, this onCreate that you keep saying here, and even we saw it for onCreate. So it's basically telling the program what to do first. And the main activity onCreation is going to execute the following commands. And here it's saying my data set, data source, load food. Now we created a data source here, right? And we created a function called load food. And on that note, let me actually also include this in our reference doc so that I can all right. Hold on, give me 1 second. All right. Okay, so data source is here. All right. So let me include this as well. All right. So now you have in the reference doc, you have your main activity code, and you also have your data source code in there. So you can take a look there if you need it. So we created a function called load food, and then we said we want the return type to be a list. And then we're calling in our main activity, and we're saying in the data source class, look, call the function load food. So what it's going to do, it's going to return the list of the following food, right? Simple. And the recycler view is going to find view by ID recycler view. So recycler view, we added it in our activity main, and this is the ID right here, right? So what is it doing in the main activity? It's saying find it by the following ID, and this is the ID that we gave it, right? And then it's saying in the item adapter, use my data set. And what is the my data set there? Well, it is simply the getting the string and the right here, right on bind view holder, it is getting the string and the image and replacing it, like I said. So this is where it's getting that data set in the main activity, right? And then this my data set is just a variable that we created with a list of food, right? And the parameters that go into item adapter are and the list, right? Because if we go to our adapter, where did it go? We can see here that it's a view and oh, sorry, that's the view holder. We can see that it's the context and the data set, which is a list of food. So same thing in the activity main, we're saying the context in which it's created and the list. And then Recyclerview set has fixed size. So when you set a fixed size as true, so it makes sure that when you're actually viewing the list, right, it doesn't when a list is longer than your screen size, a lot of things go wrong, right? So you have to specify these kind of things to make sure that the list is confined within the screen and it doesn't like compress itself just to fit on the screen. So that's when you would use a fixed size, saying that's true. But yeah, that's the code for the activity main. Like I said, I've added it in the reference document if you guys want to take a look. And with that, we are done with the recycler view. So let's see if we can actually run it. And let me see if I can fix these. We should actually be able to run and see a list of our food. So let me see if I can save this and fix these errors here, because I think it's looking for an image that I haven't yet added yet. So I'm going to add that in a little bit here, but let me see if I can run it without the image being in there. 1 second. Main activity. All right, let me make sure that this won't cause any problems. Well, I guess we can just comment it out for now until we don't have. All right. Okay, so let's run it and see what it does. So the next step is going to be, this was actually a big part of what we were doing. And the next step is actually, pretty straightforward, considering that we just actually made the recycler view. We created an item adapter. We created all the things that would go inside the item adapter. And we modified the main activity to be able to interact with all three elements of our program: the front end, the item adapter, and our data set. Which is in our data source. So I hope, like I said, that getting into the nitty-gritties can get overwhelming, but I hope you understand how it's all laid out fundamentally and how it's trying to interact with each other. Because learning the code and learning the syntax, you can do anytime, anywhere. But I think it's really about understanding how the classes are interacting with each other. All right, changes not applied. Added variables. right, let's see. All right, so clearly we can see that it displayed just the list, right? So it just has the strings there right now because we haven't added any images. We haven't done any kind of formatting to it. So this is where it gets interesting, more interesting, hopefully. So here we are going to now display a list of images using cards. And in order to do that, the first thing we want to do is add images to our list, right? And I am going to add these images in a zip file and upload it to the drive and share it with you guys. But for now, I'm going to put it in the chat if possible. But for now, let's look at where these images actually have to go, right? So where do I actually store these images? These images go in our folder called drawable. And what that folder is pretty much where all your assets are pretty much located, right? And in order to copy that and paste it here. Right, so I just copied and pasted images that I found off the internet and that I've used previously. So these are images of like food, like there's like pasta here, and then there's what was it? Oh, I should stop the build. I don't need it. It'll blow my computer up. But yeah, so it's just what's important to understand is this is where it goes, right? This is where the assets are loaded from. It's under resources and drawable, and it's just 6 images of good looking food. And then what I'm trying to do here is once I've added the food, now this is when I can actually go back to my food.kt. Yeah, so this is where I can go back to my class here, and then I can say, sorry, not my Kotlin class, my model. Yeah, it would be my food class, and then this data class here. This is where I can say I can pull from my the strings here, and then I can say that. Hold on, I'm gonna have to. Okay, this is what I'm doing wrong. These parameters need to go inside the parentheses, right? So it has to look something more like this. So what I'm doing here is passing these parameters inside the food class, and I'm saying that point to it again through the image resource. Now, where does food dot Kotlin come into play with all of this, right? Well, this food class is what makes sure that the items in the list are the text that is being displayed and the image that is being displayed is being pulled from, first of all, the list item, um, and then it's displayed to the activity main, and it is also making sure that it's actually pointing to the image and the string through the correct ID. Now, what does that mean? Well, the resources, the drawable folder under the resources is where our images are placed, right? And we haven't defined the ID of the images yet, but we're going to do that. And we're going to do that in our data source file, which should have been here, but it's not. I think data source is under here. Okay, so this is where we're going to be able to define our images, and we're going to be able to say that, okay, so this is where our images are going to be placed. So this is where we can say that along with the string, we also want an image. So we're going to be able to accordingly and I think I added this already in the reference folder, but if it's not there, let me see, let me make sure for the reference doc. All right. Yeah, so I do have it, but I have it without the images. So now I'm going to add the part with the images as well. Right. Now you have that there. So feel free to look at that. So yeah, so we added the images. We actually added the images in under the drawable, image 1, image 2, image 3, image 4, image 5, image 6, and we're pointing it by its actual name, which is image 1, and so on. And that's how it knows that these two are the same. And then the food, we are saying that the image resource ID and the string resource ID is how you want to point to the respective strings and the respective images in the list. Once that's done, you want to add an image view to your list item layout. And we're going to go to our list item layout, and this is where we're going to add our text view and also a linear layout so that it works according to a more of a scroll that we can something that we can scroll in a linear fashion vertically. Again, paste that here and add that. Right. So that's right. So added that there. So like I said, this is just adding a text view and it's adding a linear layout. And we're going to be calling on the list item in the activity main so that we can actually display it there. So that's when we're going to be using it. And then what I'm going to do is add in the list item, I'm going to be adding an image view. And all this is doing is saying that give me, you have to understand that these attributes are used to just pretty much have certain features that are available to us. So for example, text view makes sure that we can display text, and same way image view will make sure that we can actually display the image under certain constraints. For example, the height, the type, the scale type. Now center crop, what that helps us do is if there's an image, right, it makes sure that it's centered. So it's not like in a corner somewhere. It's not like some corner piece of the image. It's actually the center of the image. And it's smart enough to figure that out with this. So I did that as well. And then you would have the text or the title of the food below the image, right? So in order to do that, you would put a text view below the image. So instead of having it here, instead of having here, let me put that here. And this is where the title, that is why I've named it the title. of the food will go. So let me add that as well in the document. And all this is saying is it's making sure that there's some padding and then it's all nice and pretty looking. And now this kind of a view, all it's going to do is going to give us something like this, right? So let's try to run this right now. Let me make sure that I have everything in place, and let's try to run this. Right, and make sure we go to our item adapter, and then I remove the comments, or sorry, the commented out code here, and make sure that boom. See, now there's no red around it because now there's an image resource ID that it can actually point to. And the image resource ID, in this case, is this ID here, item image. And it's going to be able to look through the list and check for each image resource ID and then add it to the data set. And then we're calling the data set in the main activity, like I said earlier. So let me save all this and run the app. Make sure that I'm not missing anything. All right, so let's see where we are at with currently with the app. Right, so right now it's going to be a very basic looking list, right? It's going to be just images and title. But what we are missing is the material card that we talked about earlier. And that's when you include the material card inside. So you would encapsulate everything inside the material card view, right? So that it looks nice and pretty. So you would do that in the list item. Anything that deals with the front end, making it look pretty, goes in the XML documents, right? So remember that. And here, and looks like it ran. Oh, okay, it launched. All right, let's see. All right, so this is what it looks like currently, right? So how does it look like this? Well, let's compare to our list item. This is what it looks like, and it doesn't look like too bad, but it doesn't look like it's we can polish it a little bit more, right? So right now it's not implemented the card view yet because I've not run it after the changes. So all it's implemented is the linear layout, the image view, and the text view. And the text appearance, you can see that it's kind of like it's a bold. There's a bold here. And how does that bold effect come? It's through this right here. The text appearance is headline 6. So that's a property that Android, it's a library that Android lets us use to make things look prettier. So that's how we did the bold effect there. And we're going to make sure that we closed out this material card tag. And yep, so looks like we're good on that. So let's rerun the app and make sure. So this again, like right here, this is where I imported the material card, and I just made sure that there was a margin and the height and the width match parent is pretty much, it should match the size of the screen. And when I say match parent here, it knows that it's a list. This list item XML is in the layout and the activity main is parent. So it'll understand that it has to match parent accordingly. So let me apply the changes and see what it looks like after we add the material card view. And with that, I think we are pretty much concluding with our scrollable list. That is, I think, the last few parts of our presentation. So the material card view is what makes our app look like that. And on the left is what you see, what I've coded, is where you have the material card view. And this, again, is where class inheritance comes in handy, right? Um, you have the base class or the parent class. In this case, it's the parent attribute, which is called material card view. And then you have the linear layout, the image view, the text view, and the linear layout closing tag, and then you're closing out the material card view. So when you're encapsulating everything under that, that's all you need to apply it, and all the other attributes will inherit from the base class. And that's how like a very basic material card looks like on the right. And that's how we have used it on the far right for our app. And let's look at our app. Yep. So it looks like it. So it added some padding on the edges, and it added some, like there's a little bit of a shadow here. And I'm sure that there's, material card. This is a very basic rudimentary application of a material card. There's a lot of ways you can add shadows, and you can actually add some buttons there. And like in the presentation, you could have a button there saying order the food, right? And then you could have another one could be add to cart, something like that, and you would be able to add that stuff. Now, that all sounds really exciting, and I'd love to go into that. But like I said, there's only so much we can cover in a reasonable amount of time without overwhelming you guys. So depending on the response of what I get with this, I'll see if I want to continue working on the food ordering app, or we want to change things up a little bit, maybe move towards cracking the coding interview or something like that in the future. But yeah, so there is going to be a poll out, like on getting some feedback on how you like the presentation, and what you thought about the idea of the presentation, the theme. That's going to be more like a survey, but the poll will include whether or not to move forward with this app, change it up a little bit, or change it up a little bit with maybe coding in Python or something like that. But yeah, with that, we have come to an end to our presentation. And if you guys have any questions at all, please feel free to ask me in the chat, or unmute the mic, unmute your mic, or you can email me, add me on LinkedIn, or any of that fun stuff. So thanks, guys. Thanks for coming.